Part 2, operations with decimals. This we have talked about in the previous part. So when a denominator has only factors other than 2 and 5, that fraction can become repeating decimal. And we'll see in some examples. Practice problem 13. The letters V, should be W, V, W, X, Y represent numbers as shown on this number line. V and W is less than 0. X, Y is greater than 0. Okay, which of the following expression has the least value, smallest? Okay, so V plus Y, they cancel some, but maybe they're coming to around 0. V minus Y, V is negative, Y is positive. So this become even more positive, should go somewhere in here. Okay, that's B. W plus X, W is negative, X is positive, so they'll come around here. V minus W, V is negative, minus W is a negative sign, right? So this would come out to the negative of the distance between the two, so it's somewhere here. E, Y minus X, Y is positive, minus X is this part. Okay, so in comparison, B has the least value, is outside -1, is less than any of the other options. Problem 14. 5 different points, A, B, C, D, E, on this number line. The length of AD is 5.5, and BE is 4.5. If the length of CD is 3.5, what is the possible value for BC? Okay, we basically added in the possible separations for 0.5, 1, 1.5, 2, and so on. So roughly estimate how big the BC is. We'll leave this problem for the students. Practice problem 15. Repeating decimals with non-repeating part. Expressions 0.7245 as a common fraction. Okay, so this one is actually 0.724545 repeating forever. In this case, we can have X equals to 0.7245 repeating, and because we have two numbers repeating, so we need to do 100x. 100x is 72.4545. Okay, so now we subtract the 2 as we did before. So 72.45 and the 45 remaining will be canceled. So subtracting, we get 100x minus x is 99x. And then we have 72.45 minus 0.72. These 45 repeating, they cancel each other. If we line up the decimal place, right? 45 minus 72, the 45 repeating after them is going to be canceled. So this would give us 71. Okay, so x is 7173 divided by 99, or 7173 divided by 9900. So this is divided by 100, right? So we put a 100 on the bottom. So that's the fraction form. Then you can simplify. Practice problem 16. Calculate 2.48, repeating 48 plus 2.83. So we can take the integer number out. So you have integer 2, adding them together is 4. 4 plus 0.48 repeating plus 0.83 repeating. As we have shown before, you have two numbers repeating in fraction form. That is 48 over 99. This one in fraction form is 83 over 99. So this would give you 4 plus 99, 131. So then you convert this one into mixed number, and The mixed number would give you a fraction at the end. Convert that into decimal to find out the answer. Practice problem 17. 17 is almost the same as 16. So we take the integer out. That's a 4 plus 0.215 plus 0.307. So there are three numbers repeating. So that is 215 over 999 plus 307 over 999. Okay, then you add them together, convert them into decimal to find out the answer. Problem 18, find the ratio of this to that. So now we're used to this, right? 0.16 repeating, that's 16 over 99. This one is 83 over 99. The ratio of the two basically is just 16 over 83. Problem 19. How many positive integers less than 100 have reciprocals with terminating, that means finite, number of points after the decimal place? So as we said, the denominator can only have 2 or 5 in their prime factorization. So let's see, less than 100. So we would be able to have 2, 4, 8, 16, 32, 64. Multiply 2, that's 128, so that's out of the bound. So that's all 2s, all 5s, 5 and 25. So 5 to the cube is 125, is outside. And the combination of 2 and 5, you could do 10, 20, 40, 80. Okay, or 50. And there's one that we should mention in the very beginning, that's number 1. So how many in total? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, total of 14. That would have terminating decimal representations.